Hello everyone, I hope you're all doing well today. Welcome to our applied mechanics lesson. So in our previous video, we went through the sine rule and we can use it in one of two ways. That's either when you want to find an unknown angle or if you want to find an unknown length. Now, I want us to look at the cosine rule today, and this will essentially be applicable if you have maybe one of each. Let's take, for example, triangle ABC. A, B, C, right? Let's say we have an angle of 60 degrees over there, and we have a length of 20 over there, and then we have a length of 10 on this side, okay? So you will remember that how we go about the sine and the cosine rules. If you have labeled your corners A, B, C, you'll essentially label what's across to it as its corresponding letter or alphabet. That's essentially how we go about the labeling, right? So by looking at this diagram, we have the angle of C, and we don't have the length of C. It's unknown. Then we have the length of B, but we don't have the angle. It's unknown. We can just let that be theta. Then we have the length of A, but we don't have the corresponding angle, so that's unknown, right? That's essentially where we then adopt our cosine rule. So our cosine rule has about 3 rules. It's actually one, it just gets rearranged into 3 depending on what you have and what you're trying to solve. Okay, so for starters, we could start with, if you're trying to solve for the length of A, you can use the formula A squared is equals to B squared plus C squared minus 2BC cos of A. Alright, this will be applicable if you have an angle A and you have lengths B and C, and you essentially use those to try and calculate your A squared. Then if your B is unknown, you can say B squared is equals to A squared plus C squared minus 2AC cos of B. Okay, similarly, if we're trying to solve for C or C squared, you can say C squared is your B squared plus A squared minus 2AB cos of C. Alright, these are the rules that govern your cosine rule. They're there. Okay, you don't need to try and figure out how we came up with the formula, how we came up with the equation. Those are the equations that are there. That's essentially what we use. Now let's take our triangle on here and try and take it for a spin. We already say we have length of A, we don't have an angle, we have an angle C, and then we have length of B as well. So by looking at what we have and looking at how best we can go about solving it, we have the angle at C, right? We have a length A and we have a length B, right? So we can adopt this side to try and find the value or the length of our C, right? So I'll just write this out again. C squared is equals to A squared plus B squared minus 2AB cos of C. Okay, now looking at our length of A is 10, so it's equals to 10 squared. Our length of B is 20 squared minus 2, 10 times 20, and our included angle will be a 60. Okay, then you can plug and play. 10 squared is 100. 20 squared is 400 minus 2 times 10 times 20, that's 2 times 10, 20 times 20, 400. Then cos of 60, cos of 60 is 0.5. Okay, then we get the 100 plus 400 is 500 minus 400 times 0.5. So essentially you end up with 300. But remember, this is C squared. It's not the final answer. That's just C squared. So C will be the root of 300. And that gives me 17.32. and that's in meters or whatever units you're using, okay? And that's essentially step one that you can use to try and calculate your unknown length. So now we know that the length of C over here would be 17.32. Let's assume it's in meters, okay? Then let's say we now want to find the value of our angles on here. Let's say we want to find the value of theta on there, right? So using the known information, we now have the length of C, we now have the angle at C, we have the length of B, we don't have the angle at B. So remember that we can now use our sine rule, and it says A over sine A is equals to B over sine of B is equals to C over sine of C, okay? And we've already determined that we have stuff for C and we have stuff for B, and we have stuff for A as well. It's really not complicated. You could just pick which two to use, but we are trying as best as we can to use the given information because you don't know if what you've calculated on here is correct. And as much as we're confident in it now, you don't know for sure, and you don't want to use an answer that could have a mistake in it. All right, so you want to try a level best to try and use the given information so that should anything happen here, maybe you mess up your signs, then you can still kind of secure a couple of marks on this one, right? So we said we're going to stick to B and we're going to stick to C, okay? So we will then say B over sine of B is equals to C over sine of C. So the length of our B is 20. Then we have sine of theta because that's what we are trying to calculate. Then the length of C is what we calculated. Here I going against my own words. Anyway, let's stick with it. 17.32. I think I should have picked A, but it's okay. 17.32 over sine 60. Right? Then you can cross multiply. Then on one side you will have 17.32 sine of theta. On one side you'd have 20 sine of 60. Okay? Then we can divide by 17.32. Divide by 17.32. Alright? Then we'll still have sine of theta is 20 sine 60 all over 17.32. Then theta would be shift sine of that 20 sine 60 over 17.32. Then you can plug all of that in your calculator. 20 sine of 60 over 17.32. Wait, what happened? This girl doesn't want to behave. Okay.